Yeah, I'll send you. Yeah. How are you guys? Welcome everybody to another session, another talk. Today the guest is really special because he is really special. We have Let's welcome our guest Otavio. Welcome Otavio. Thanks for being with us.
Oh, hello everyone. I'm super happy to be here. Let's talk about open source JVM and how the JVM works internally. So, I'm super glad to be here and have this time uh, to talk
Thank you.
more about one thing that I enjoy a lot that is open source and naturally the JVM.
Thank you so much. That's really amazing. And also, thank you so much. We are really glad the whole Riyadh Jug audience and members are really eager to watch this talk, and they're really happy for accepting our invitation. So let's give a little bit introduction about Riyadh Jug. Riyadh Jug is Java User Group, is focused on Java related stuff. Everything related Java and around Java is we will be talking about in this jug. So we welcome everybody from any place in the world. We welcome any speaker. Please do reach us and subscribe to our YouTube channel. And we urge the audience and who are live with here with us, please drop your questions in the comments below, and we will be answering them, of course, during the session. And let's give a very basic introduction to our guest. Otavio is a worldwide speaker. He is a Java champion. He is a Jakarta ambassador. He's a book author. He has, I think, more than 10 books, authored 10 books. So he is a very active contributor to the Java community. So let's welcome our guest, Otavio. The stage is yours. Good luck.
Okay. Thank you everyone to be here. I'm super glad to here to talk more about one thing that I enjoy a lot, and that really changed my lifestyle, my everything. It is talking about the JVM. So, um, naturally, I do have more experience contributing to OpenJDK. I'm gonna use that to explain more about the goals that I and how it works. Naturally, the JVM is a huge universe. It's natural that I won't be able to talk about everything, but hopefully I will cover and also do a quick overview about the internals of JVM. Okay, so if you do have a question, please let me know. It's a huge pleasure to answer those questions that I know. Remember, I be part of the core API. I am executive member of JCP. Um, so I know a few parts of the JVM. So what I know, I super glad to answer your questions, and what I don't know, I can find who can take that answer for you. Okay. Uh, the main point here is talking and exploring more about the JVM, so the Java Virtual Machine. One thing that I enjoy a lot inside the JVM is we do have the war philosophy, so the write once, read anywhere, and mostly of that we can say thank you for the Java, or sorry, for the JVM itself. Um, and that is it. So let's talk more about the JVM and how it works. The first step, naturally, explain what's JVM and the main goal of that. Naturally, you might know that, okay, for running my Java application, I need to have my execution engine on my JVM to make it possible, right? So basically, write the code. I do have bytecodes, and based on the bytecodes, the the JVM gonna read these bytecodes and make the execution of this bytecode. So we are talking about two process: the pre-compilation or the compilation to a virtual machine, and then the execution inside a virtual machine. On this case, the Java virtual machine. And that's why I make Java Java. So basically, we do have the bytecode that we work in several JVMs naturally. However, to make it possible to write really anywhere, our interpreter must be native. So that's why we do have JVM working to several platforms. That's why you need to install the JVM for Mac, Linux, and Windows. We don't have a system operation that will work for everybody, for every situation. Furthermore, we also do have the architecture. So we have 32 bits architecture, we do have 64 bits architecture, and so on. So that is the main point of the JVM, be multi-platform. Okay. Um, and that's our process. So what do I have? Naturally, I write the code. So I will write down my hello world Java with static public void main, and then this code gonna be compiled, and finally I will convert this compile code in a second class or second file that is my class file. Again, that is basic of the basic, right? So given that class, I will load that information to the my execution engine and make it running inside my application. And as I said, we do have one JVM to each platform or architecture that we do have. So to make it possible to run the Java inside Mac, it is because I do have the JVM for Mac. The same thing happened with Linux, with Windows, and so on. And if you remember, I don't know who is familiar with Java application layer. So we do have several layers here. We do have for example, those four layers, as you can see. So naturally, we do have the hardware that will communicate in the structure and binary code. Then we do have the structure set architecture that is our ISA, the driver, okay? And based on that, I have the communication to make it possible. So I have the instructions, I have the driver to make it possible, and then I do have my system operation. And based on that, I naturally go have my application on that layer. So if you're familiar with the modern system operation architecture, you might be familiar with that. If you're not, my recommendation is to check the Turnbull book around modern operation, modern system operation. This book is awesome. Naturally, I won't cover the whole details of each layer here, but what matters to us is usually Java goes in that layer. So Java is application, so it's run on the top of the system operation. And the magic part of Java, it is because I can run some instruction directly to the instruction machine. Okay. Sometimes I do have instructions to go directly to the hardware. That is the powerful of Java. So right now, I talked about the JVM, what is that, and why you do have. Just to remember you, I starting with my Java class. I compile that code to the virtual machine language or bytecode in our case, and then the virtual machine will interpret that on execution. When this happens, I will read and interpret my class file, and every class that I need to put inside my execution engine or my JRE, I have to go to this flow or this process. So I need to loading this class to the memory, do the verifications, that is instruction to do the verification. For example, um, the security code that is calf baby. Then after the verification, I check the version of the class. If everything is okay, I will link and then allow to initialize the class. After that, it's gonna consume memory inside the JVM itself. And we do have this register inside the JVM in general. I'm using here OpenJDK and naturally the reference, the Java Virtual Machine reference to use these instructors to have some notes. Naturally, every implementation might vary based on that implementation and so on. But the point here is we need to pay attention on this kind of variation. So I read the class, I will load, link, initialize, move on to the runtime data area, and based on that, I will interpreter, execute, optimize on execution with just-in-time compiler. Naturally, with the time, I will consume memory. So I need to take out this memory again using garbage collector. Sometimes I need to run native code in Java. So I have the GNI or Java native interface, and naturally that will communicate with Java native memory. So the library go to natively. And based on that, as I mentioned, we do have kind of heaps of memory inside the JVM. Once I work in native, so may vary from the system operation or the architecture. And naturally, we do have some Java heaps memory. One of those memories will be shared by threads. Another one is to each thread, I will have a unique history in the memory. For example, here, I do have the method area that I'm going to explain later. Is one for all the threads. The heap is the same. However, the Java stack and PC or problem counter is exactly one by thread. And the native method stack as well. So it is one by thread. The first one that we cover here in the register is the PC or the program counter. Basically, it is one by thread, okay? And each one of those is to register the instruction that is executing right now. If the instruction is native, as I said, it may vary the size, the instruction itself, and so on. So it's uncertain based on the architecture, 32 bits, 64 bits, system operation, or if we are talking about the Java execution, we do have a type that is the return address. It is a Java type, but naturally we're not able to use that on your code. So it's a JVM type. Okay, so the first one, PC or problem counter to take down or to see the thread executions. Naturally, because it's a thread execution is one by threads. And based on this PC, we might have two different values. One is for native, that is uncertain, that may vary if it is Linux, Mac, or Windows, and also may vary from the architecture perspective, 32, 64 bits. And when you talk about return address, it is around Java structure itself. So if your method is native, gonna have the interrogation because it's uncertain. But if it's Java methods, you'll be there. So the instruction will be as return address. Just remember the PC, the program execution, line by line of that. And then we do have the Java stack execution. So every method, we do have the frame. And the frame, basically, we have three pieces or three parts of these executions. We do have the local variables. So the workspace that we are working on that, the operand stacks is like a queue. So it's kind of assembly. So I need to go instruction by instruction execute, and then the result going to be on the top. And then I can take this return to storage or return or do something like this. And naturally, also when we're talking about Java, we are talking about methods, class, fields, and the structure of the class itself. And those things has a pointer to take this structure. For example, I do have my uh, person class with person fields, with name fields, age fields, and a method that say hello, where I have the concatenation of the name plus the age. So I need to have the structure, the structure of the person, the method, the field that I do have. So it's a pointer. I have the operate stack. So I will do the line by line of the structure. And finally, the local variables that I'm executing inside these methods. Okay. Also, if you're talking about the static methods, it is only the variables. But if we are talking about instance methods, we need to have first the instance and then the parameters. If you are familiar with Python, or if you are not, if you're curious to know, you can check the Python methods. So usually the first parameter itself, so it is the method, it is the instance itself. Basically what the Java does is hide and abstract that for you. This is a classic example of sum two numbers and then take out the result. So 10 plus 20 will return as 30. As I said to you, it is a queue. So I need to load first the 10 and then put in the queue the 20. And then the result of that instruction going to be at the top of my stack. And based on that, I can naturally return, store in a variable, and so on. So it's up to you. So the whole point here, it is work exactly like assembly, as you can see. So the key, the queue, the instruction, the queue, the instruction, the results at the top, and then you can operate whatever you wish or whatever you want. The local variable, as I said to you, so it may vary method by method, but as I said, so if I have the method, as you can see, the reference method, so the method that is not static, the first parameter will be the reference, so the instance that I'm calling, then the parameters. If it is static, I don't need to have the reference because this method belongs to the class itself. So we don't have this first variable here. So there's no reference when we do have static method. Okay, I talk about the PC, the program counter to take the thread execution, then the frame, right? So the 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 Java stack, where we have a couple of components, the operand stack to execute, the local variables to storage to be the work storage to the operation, and naturally pointers or dynamic link to the class that is executing right now. So I need to know that my person class has name fields, get name method, and so on. Then we have the classic heap where we hold the live objects. So we have the pointer to the reference of the class that I'm gonna cover late. So because every class, every object has its own structure and then the data. The data itself go to the object pool, as you can see, and the structure of the class goes to the method area. Okay, so my heap has the objects that is alive, and based on that, I have basically two components: the structure based on the pointer to method area, and finally the object pool where I will hold the objects, the data of those objects. And naturally, also talk about data in Java information. The first thing that might come out of your mind is garbage collector, right? Because we're gonna consume a lot of memory and then somehow we need to take out those. Okay, so basically the mark sweep is this process. So I need to identify the place that I'm not using anymore, the data that I'm not using anymore, then remove from the memory. And this, because of that, I'll have some gap of memory. And my last step is the fragmentation. That means unify, so save space to more memory allocation. Okay, so mark, identifying the free or the space that I don't use anymore to make it free, sweep, remove it, and finally, I need to somehow identify that the place is available and I can use and I can allocate. Okay. And based on that, I do have a couple of garbage collectors, but at the end, the object is still the same. So I need to identify the object that I'm not using anymore, remove, and finally find some way to do the defragmentation to allocate memory better to make it ready for use as soon as possible. We do have several garbage collectors. With the time, we change. We have more, we have less. But the point is, I will cover a little bit of those garbage collectors today. Naturally, I won't go deep on those, especially because garbage collector is a huge universe, and I do recommend you the Monica book about it. So the proposal of my book is to go shallow of several topics. So I'm gonna do for you an overview around the garbage collector, JVM, link, and so on. But naturally, it's a huge word. It's impossible to cover everything in just 200 pages. Okay. So the first one is that I'm gonna cover is the monocore. So the serial garbage collector. As you can see, I do have several memories, but I'm gonna use a single core to mark, sweep, and then this fragmentation. And probably you might notice that this defragmentation moment, it is sometimes what happened with the stop the word because I need to allocate pointers, reference, and so on. Then I can use more than one core. I can use parallel garbage collector. That's mean I can use multiple core On this case, given that I do have 4 core in my CPU, I'm using 4 core to mark, 4 core to sweep, and 4 core to defragment the data in the memory. On those cases, I still stopping everything, but naturally with more core, I will do it more quick than before. And then with the time, the JVM team, the OpenGK, find new ways to reduce as much as possible the stop the words with more efficiency to handle a huge amount of memory and so on. Naturally, the first one that we cover quickly today is the garbage collector first. That come out from, if I'm not mistaken, Java 7, and then become more and more popular with the time. So we have several chains in Java 9 and then so on. Basically, what we do have, we have several space with the same size. Then we do have the definition of liveness space. That's basically check, okay, each space has less objects live, then it will move this object live to another free space and then make this register space available to write anything again. So take here, for example, in my first stage on the left, I have several spaces in the same size. So with 8 objects alive, 1 object alive, 5, and then we do have white space. That means free space to use. And the first interaction, I start to move the liveness object to a free space. That means my one was moved to a white space here, as you can see. So it is white space here, but here is not anymore. And then make this file, the space that was occupied as free space. And then I keep that to avoid this fragmentation process, because right now, if I have I square with a unique instance alive, it's much easier move that instance and then make available everything else. And that is the premise of the garbage collect one. So the main goal is to avoid stop the word as much as possible, because it's increased the latence, the throughput, and so on. The main goal here is to make it easier for us to do this kind of interactions. Then we do have the Z garbage collector. So briefly, it is the interaction between virtual memory and physical memory. I do have a pointer to this physical memory. The idea is still the same, but instead of having the same space, we have a pointer of the memory and representation of the physical memory to avoid again the nightmare of stop the word. This one here is not mine, so it's a recommendation that I took from Bruno Bord's presentation, DevOps Belgian. If you want to know more, inside my book, I do have the whole reference to Bruno Borges. But if you don't want to have this book, you can see his amazing presentation around the JVM and the optimization to garbage collector. Bruno Borges is the person who works in the product for Java at Microsoft. So we do have this table with the configurations based on the number of cores and the recommendation configuration for you. For example, if you have a unique number of core, naturally go for it for serial garbage collector. And as much core you have more options to use and explore. For example, if you have if you have 2 cores and less than 4 GB, the parallel one might be a good fit for you. So here it's a table from this Bruno Bord's presentation that you can have on both. So You can use YouTube like you're using right now to search for Bruno Bard's presentation at DevOps Belgium, or you can take the link at my book. But what matter is don't let the ergonomic work for you. So define the garbage collector configuration, try, and of course, don't need to start from scratch. You can use this table to make your life easier to do this configuration, to do this turning inside your application. Okay, right now I talked about the JVM, why you do have it, the type, why you do have water, the right ons to read anywhere, mostly because the JVM, and that's the main reason that we do have several implementations of the JVM to several vendors, several system operation and self architecture. I talk about the register, and naturally, also we're talking about uh, the JVM. We need also to talk about the JVM types. Okay, so is there one question about the default garbage collector Java 17? I won't do a spoiler, so my recommendation is go for a Bruno Bartra presentation where he will explain to you how ergonomics work. So my book has some types, some tips, but basically it's not simple like that. So it you check the number of memory, processor, and based on that, the ergonomics will work for you. But put in your mind that premature optimization is not good, and the ergonomics is basically a premature optimization for you. So avoid to use the default garbage collector as much as possible. So check the Google Browser presentation where you can take a look and learn more about it. So that's my advice. Around the JVM, as I said, we have types, basically two types, the primitives and reference. So Boolean, at the end, we are talking about the int. There's no Boolean in Java words, unfortunately, especially because when you talk about bytecode, we have to have byte instructions. Um, Ambu answer, okay, what is the default garbage collector in Java 17? And I will reply with the G1. As I said, it's not simple like that. So take a look because it is based on economics. So the memory that we do have, the processor that we do have, we can say that mostly of the case is more serial garbage collector than the G1. Um, we do have two JVM types. So the primitives, like we are usually using in reference, where we have the class and array. Other primitives, as I said, Boolean at the end is a int, especially because the instruction in bytecode must fit in a byte. Then we do have numbers that you might know, double, long, and so on. And the one that you might not know is a return address that explains to you that is about the PC or program counter to take your instructions. Right now, talking about my favorite topic that I enjoy so far, that is the bytecode. So basically, as I mentioned for you, everything goes to bytecode instruction. And based on that instruction, the JVM will read and interpret that for you. One tip for you, if you want to read the bytecodes, check the prefix of the instruction. So if it starts with I, is for integer operation, L for long operation, S for short, byte, short, float, double, and A is for reference. Okay, what is Boolean? So as I said, there's no Boolean. At the end is an int value. And here we do have some sample of instructions. So for example, I add, as you can see, it starts with I. That means I'm gonna do some operation with integers. L longs, F floats that is double. So Otavio, what happened with another types like short byte? So I will convert first to integer, do the operation, and then convert to again to short to byte and so on. So at the end, to do some operations, we need to convert to integer first to do that operation. So a lot of people ask me about instructions, methods using short instead of int. At the end, a short in the method will occupy the same int size to the operation. Furthermore, I will need to process more because I need to convert the short to integer to the operation and then return the value to short. So if you do have short in the method only, it might not be a good idea. If your goal is to save memory, uh, of course you can have in fields and things like this, but inside the methods does not make sense. Especially because, as I said, I need to do more operation to do the conversion to from, and then at the end I will occupy like an integer. Then I have the subtraction, multiplication, division, and as I said, it's a bytecode. It should keep as 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 short as possible because it must fit in the byte instruction. Okay. Here is a sample. So I do have my int a, int b, and then I will store the result in a variable. So a plus b, and then that instruction that we get. So if I put that in methods, remember the Java optimize the bytecode for us. So if I can convert that to constant, I will convert that to constant. I will avoid the processment. So Java takes as hybrid solution. So it's not totally interpreter, it's not totally compiler. We do have virtual machine to interpret that to the system operation to native code, and that makes Java more efficient in some case. For example, here I can see I can optimize instructions. For example, instead of have 5 and 7, I can load directly from the stack. I can do operations and then storage and then return. Sometimes I can just load directly the result if without doing the operation itself, because the Java compiler will check, okay, 5 plus 7 is 12, so I don't need to do that operation on real time. So what can I do instead? Load directly the 12, and that is it. So I don't need to do anything else than that. Okay, I explained several native primitives operations. Right now, let's talk quickly around the reference methods. For example, the classic that most of you are using, the getters and setters methods. So basically, this is a simple sample of the get name where I load my fields. As you can see, I do have the A in the front. Then I get the information from my fields. So in this case, the field name. And finally, I will return as reference. As you can see, the prefix here is UA. So I will return my reference, naturally string reference. On the set method, I need to load that from parameter. I need to load that at the my field. I need to put that on my field and then return nothing. So I need to do the void. There's a simple case, naturally, of the bytecode destruction. The point here that I'd love to explain to you is first check the prefix of the index of bytecode, and second, based on that, you can understand how it works entirely. And as I mentioned for you, it's assembly. It looks like assembly code. So I do have a key where I go instruction by instruction until the end. And based on the prefix, I can know exactly the type of operation that I'm doing. So I, L, F, D, some conversion like S to one, um, B to one, and so on. Okay, I explained to you right now the overview of the JVM, the garbage collector, how it works, and these details. Of course, remember, we are talking here for 40 minutes. It's impossible to give the whole overview of the JVM on that time. The goal is still the same, to give you the briefly overview of what's going on inside the JVM. And actually, the next question is, okay, Otav, the Java ecosystem is based on frameworks. Everything goes to frameworks in Java, so that's why we do have annotation. We do love annotation a lot. And basically, it's happened because we do have a huge ecosystem of frameworks. Okay, and the first question is why? Different of all the language like Python and Go, if I'm not mistaken, they don't have those huge amount of frameworks. Basically, okay, JavaScript can be higher than us in number of frameworks, but the point here is the Java is Java also because of the ecosystem. So why do have these frameworks to make our life easier and naturally to navigate to different paradigms? The classic one is data, where, for example, I have my database that lives in a different paradigms than the Java. So Java is objects, database, if the relational is relational structure, and naturally I need to have some communication. I need to teach Java how to convert the Java code and put inside my relational database and so on. And the first version of Java, I did that with this XML file. So basically, my framework engine needs to read the Java code, the Java instructions, need to read the XML instruction, and based on that, do the conversion operation to and from my database in this case. But remember, the Java world is much beyond the database. So we do have securities, integrations like off, to, and things like that. JWT, we do have ATP requests. We do have WebSocket requests. And most of the time, we want to achieve that using simple annotations to make our life easier. So most of the time, when we talk about Java, is the navigation through several layers, tiers, and of course, using some way to somehow to make our life easier. Thankfully for the framework that does exist for us. And that's why we do have this. So naturally, I have my Java application, I have my database, and somehow I need to do this conversation, I need to do this mapper and the communication to from any paradigm that I do have. So not database, but also ATP requests, especially because right now, most of the time we are talking about REST applications and so on. And that's happened because we do have this communication. Return here for a moment. Naturally, right now we are using annotation instead of XML file, but the legacy is still here, so we can still using legacy file like XML file to make this configuration. And we do have several strategies to read these annotations or XML file. The first one is doing that on build time. As everything software architecture and software design has a trade-off. So the build time, you can see that in several frameworks such as Quarkus, or any Java notation processor frameworks such as MapStruct, for example. So during the building of the application, I will read that annotation. So I will load parts of configuration. I will analyze those dependencies that I do have. I will include that dependency on my tree. I will create my structure. And based on that structure, I will put a package. And with the whole code ready for execution, I will have the package, and then naturally I will execute as any code that I do have. So with the build time frameworks, I will read the annotations, do the whole conversion on build time, and make it ready to run on either native or the JVM. Okay, the advantage for sure is the warm up because I can make it faster instead of read and process the whole information on the execution. I can do it on a bit of time. I mentioned Quarkus, but there are more. For example, Micronauts and so on. So I have this advantage, but as usual, I have some cons. That is, for example, I cannot have the same flexibility. I cannot define library or runtimes and so on. I can do whatever I wish in a bit of time, and naturally, the build time will take more time to make it happen, especially if you are running native code. And on the other hand, we do have the framework that is capable to read the annotation on runtime. Basically, I will compile the application with the annotation and done. And after that, when my application is executing, I will load these classes, doing the process flow, read this configuration for either the XML file, JSON file, or annotation itself, analyze those dependencies based on that annotations or file configuration, create a structure, build the dependency tree, and finally execute the code. As you can see, previously I put a lot of jobs on my build time to make tiny delay of execution to make it faster, but I lost my flexibility on runtime. And on the other hand, I put a tiny effort inside my build time, and I did a huge effort inside my runtime. I get the flexibility, but naturally I need to do the process to read information, and it might take time to warm up your application. It might need time to make your application ready for more requests. For example, Spring, right now they do have the Spring Native or Spring Regular. So Spring use a lot of reflection. CDI use a lot of reflections, and so on. Another point, when you talk about JVM and different of another language, we have a huge amount of flavors. We do have the SDK man, we have the OpenJ9, we have IBM, we have um, hundreds, I guess. We have a huge amount of JVM vendors. Okay, it is not only about a single vendor. We have a huge amount of it. And to make your life easier and of course test, you can do and you can use SDK man. So it's a nice and easy way to update, use here I now mention GraalVM. Naturally, you can check out several videos, articles, and tutorial about the GraalVM. It's fabulous JVM where you can convert to native. But the point here is we do have a huge amount of JVMs. So you can explore, you can use, you can enjoy, and so on. That is all for today. So hopefully you enjoy. It is 50 minutes of presentation, talk about how the JVM works, the runtime, the compilation, the frameworks, the difference between runtime and build time, and how to use and why you should use and the trade-off, of course. And that is why what I do have for today. So as I said, we have free books to give for you. Um, let's wait a little bit. Hopefully, we have more people. And if you want a book, please let me know so you can do any kind of survey about this. Hopefully, you enjoy. And if you want to know more about me, my name is Otavio Santana. I'm a software engineer and architect. So I have I'm Java champion, Oracle based director, JCP, and I do a lot of open source. I contribute a lot of products. I still executive member of the Java or the JCP, and I wrote several books in the area. So hopefully you can enjoy some of those are for free. If you check out my website, you can go and you can check those books. So go to otaviojava.com where you can take one of those books. Naturally, you can take those one for free. So let's check the question. Java was designed for platform dependence. Did provide a good performance for long running service? Ahead of time has your own use case. Also, no framework not ready for native yet. Um, Thank you. That's a good point, right? So everything is around trade-offs. So yes, you can do your just-in-time compiler optimization. You can use native if without the JVM. Remember that there are several cases where people decide to keep inside the JVM because the long term, the JVM will work better than the native code because the just-in-time compiler. The case that I do have using native code mostly are around um, serverless Java application. Those are a use case for that. Um, let's see. So yes, the beauty of the JVM, the huge amount of JVM is as Ambu said, we have different types of product service. For example, Azure has the C4 garbage collector. Okay, that's all for today. If there is no questions, and you can reach out and foresee the free book. So check out. So you can send me an email um, about this presentation. Here, type about the presentation. I want a free book um, about the JVM. Okay, we do have one question. What is the impact of not optimizing the default garbage collector? So you might not using the memory. You might not use the CPU. For example, if you have 4 GB of memory and you don't define the garbage collector, you might not use the whole memory. You might not using the best garbage collector for your case. Okay, so those are a good case of not letting the default garbage collector, because if you're not defining that, again, check the bulletin board presentation. You can see that I will increase the number of processor, I will increase the number of memory, but am I using some serial garbage collector instead of someone that can take better advantage of the number of core that I do have and number of memory that I do have. When deploying to Kubernetes, will things change? Yes, because we are talking about container, right? So this way we need to think about the memory space and things like that. In the previous Java versions, um, we had the issue because the JVM has no idea about it was running inside a container. With the newest version, it has several optimizations. And but yes, I mean, if you do a decent job with the garbage collector configuration, um, you can use as outside a container. But the point is configurations. Check it out and keep the latest the latest version, because as late as possible, we're gonna have more efficient, optimized working with container. Yes, as Ambu said, so if you don't define a good garbage collector and let the ergonomic, you're gonna have a huge amount of pause over time, and sometimes you're gonna have the free CPU, so not even high CPU usage, but free CPU. So you start wondering, okay, I have a lot of memory, why I'm doing a lot of stop the words and things like that. So that's all for today. Hopefully you enjoy. So thank you.
Yeah, thank you so much, Otavio, for this amazing presentation, amazing talk. Thank you so much for your valuable time, valuable information, and really thanks for the audience for their contribution and for their questions. And looking forward also to meeting you again and again in future sessions.
Yes, it's my pleasure as well. So hopefully see you soon.
Thank you so much. So we are ending the session now. Thank you. Cheers. Bye bye,
Okay, bye
guys.
bye.